So you're looking for this 13th root of 1 plus radical 3i, and you have to find the value of z which satisfies this equation and has the second smallest positive argument, and your angle theta should be between 0 to 2 pi. Express your answer as the Euler form. This is called the Euler form, but you're really looking for the r and theta, so you're really looking for the polar form answer to this. So first, to solve any kind of equation like this, you always need to convert this into the polar form, and you could use formulas to do that. You could use formulas to convert, like the r would be square root of the a squared plus b squared, and which is the case that you have 1 plus 3, which is 4, so that's 2. That's easy. But the angle theta, you have to use the tangent inverse of b over a, so it's radical 3 over 1. And then the quadrant is important. 1 plus radical 3i is in the first quadrant. Here's 1 and radical 3i. So this is 1 plus radical 3i. It's in the first quadrant. In this case, you don't have to add anything, but there's this extra angle that you have to add to modify the tangent depending on where you are at. If you want the angle to be between 0 to 2 pi, you need this to be 0, then pi and 2 pi. So that's one convention. There's another convention which gives you which is 0, pi, negative pi, and 2 pi. No, 0 here. This is a different convention because that's going to give your angle theta to be between negative pi to positive pi. So that's why we should be using this convention. Well, it doesn't matter here because we're in the first quadrant. In the first quadrant, you don't change anything. And if you know the tangent of 60 degrees is radical 3, then you would know that since this is 0 and this is 60 degrees, adding these will give you 60 degrees, which in terms of the radians, it will be pi over 3. Okay, so we have pi over 3, and therefore we have, if I say z is equal to some r angle theta, different from these two r theta. This is just a formula. I should have summarized what this means. This means that 1 plus radical 3i is same thing as 2 angle pi over 3. That's what it means. Okay, so we have this 2 angle pi over 3. No, for the right side, but if I let z as r angle theta, then the z to the 13th power by de Moivre's formula will be this. Okay, so going from here to there is what we call de Moivre's formula. Okay. All right. Since this has to equal to this, or 2 angle radical pi over 3, 2 angle pi over 3, you have r to the 13th power angle 13 theta equal to 2 angle pi over 3. But what does this mean? Well, r angle 13 theta equals to 2 angle pi over 3 means that r to the 13 is equal to 2, which gives you that r must be 2 to the 1 over 13th power, and 13 theta is equal to pi over 3, which will give you that theta is pi over 39. However, this is not what the question is asking for. The question is asking for the second smallest positive argument. And what is this about? Well, you see, if you have 13, you expect 13 different solutions in the complex plane. That's a big difference between solving such an equation in the reals and in the complex plane. You can have you have at most you have the same number of solutions as this number here. Okay, so this is only going to give you one answer. Therefore, you have to think about all the other possibilities, and to do that, what you think is you come up with all the coterminal angles of pi over 3. See, these two angles don't have this to be the same in order to be the same number on the complex plane. They just have to be coterminal angles, meaning that here's 60 degrees, but you could also have another one that goes 360 and then beyond that to give you 60, which is 360 degrees plus 60, which is 420 degrees. That's coterminal with 60 degrees. And because they land at the same spot, even if these were just coterminal, they are going to give you the same answer. So 13th theta could be pi over 3, or it could be 2 pi plus pi over 3. But wait, this seems to be going endlessly. It could be 4 pi plus pi over 3. Well, what you need to remember is that because we have z to the 13th power, we should only have 13 answers. So you have 1, 2, 3. So this is 0 times 2 pi, 1 times 2 pi, 2 times 2 pi. So the last one would be 12 times 2 pi plus pi over 3 to get exactly 13 solutions. Okay? And then, so we divide, and the answer would be like pi over 39. And then, what is this? 7 pi over 39. And so on and so on. Okay? It looks like it's going to be, let's see, it's going to be something like 1, 7, and then another 6 added, so it's 13 pi over 39. And then, so in general, it's going to be 6 times some number plus 1 pi over 39. That's what we have. Now, one way to figure out which one has the second smallest would be to actually compute all these one by one. You want to, so for example, if you have this, and if you want to know what number this is, you have to use the following identity. 2 to the 1 over 13 angle pi over 39 should equal to this formula, r cosine theta plus I sine theta, which if you multiply, that means this is a r cosine theta plus I sine theta. So you have to punch into your calculator what is 2 to the 1 over 13 cosine of pi over 39 plus I times 2 to the 1 over 13 sine pi over 39. Okay. So I think what happens is, let's see, what does this mean? It means that we have to find something that, if you use this formula, you want to have something that's just before 90 degrees. Here's the 90 degrees, and to be positive, it has to be just before 90 degrees. And it has to be slightly after 270 degrees. And I think that's the key. Something that's slightly before pi over 2 and something that's slightly after 3 pi over 2. Okay, so what's like right before, well, half of 39 is, well, let's see, 19 times 12. Yeah, so 19 times 2 is 38. So 19 pi over 39 will be just before pi over 2. But it's also true that, let's see, what's 3 over 2 times 39? Right, so it's like I need to use a calculator for this. 3 times 39 divided by 2 gives you 58.5. So 59 would be the one that's just after this. So you're going to get 59 pi over 39 as the number that's right after this. Oh, but the problem is 59 is not 59 and 19, these are not 6k plus 1 type. So, oh, this is, so if k is 3, then you're going to get 19 pi. See, actually, I'm actually working lazily here because I should really have figured out the rectangular form by punching in all these numbers. But this works too. Okay, so this is 59. What is that? Oh, 59 is not one of these numbers. So see, what happens is if you have 6 times 10 plus 1, 61 pi over 39 is the first one that's after it. Okay, and then the one before it would be 7 pi over. So here's how it works. You have 3 numbers that are in the first quadrant, and 19 pi, actually, sorry, 4 numbers before the first quadrant. So 19 pi over 39 would be the closest one, and then there's one which is 61 pi over 39, and that's slightly more angle from the 270 degrees, but then 13 pi over 39 is much more here. So if you're looking for the one that has the second smallest positive one, then you would look for this one after comparing all these angles. So that's like another way to do it. If you don't understand what I'm doing here, I think it's best to just actually calculate all these, look at the positive ones, but you can choose. I mean, if it's not in the first quadrant or in the fourth quadrant, you don't have to do it. So you really have to do these 4, and then starting from 61, try until 12 times 6, 73 pi over 39. So do these numbers and just pick which one ever is the has the second smallest positive value, because that's what the question is asking for, second smallest positive argument. But I think I figured it out now. So I know that r would be, since r to the 13th power is 2, r must be 2 to the 1 over 13th power, whatever that is. And angle theta would be the 61 pi over 39. Yeah. So that's what it is.